going to be absolutely terrific and have a lot of great content, a lot of good meetings, a lot of good sessions, catch up with one another. Usually in years past, we've only had 3 months between Connect, so we had 6 months since Macau. So that's given us extra time to make sure that this is really going to be an amazing week. One of the things we're going to do this morning is we're going to have a very innovative keynote from our CEO, George Gray, with support from a number of people within Linaro. I think you'll find it very interesting. The other thing is, from time to time, someone comes up with an idea, or a group of people come up with an idea that's just so creative, and it captures everyone's imagination. And everyone thinks about it, and they go, wow, that's really interesting. That really turns the world in some way on its side. Imagine if that took hold and actually was used and was successful. So we have one of those ideas today. It comes from the Google project, Google ATAP team, Advanced Technology and Projects. And Paul Aramenko is here this morning, and he's going to share with us insight on what Google calls Project Ara. I think everyone will find that really interesting. There are a number of themed days this week. Let me give you the next slide. There are a number of themed days this week. Tuesday is Digital Home Day, so there'll be keynotes around digital home. There'll be activities. There's a track on LHG for Tuesday. Wednesdays for LNG and Networks Day. There'll be a lot of interesting demos and ODP demos on Networks Day on Wednesday. Sorry, Wednesday and Thursday are swapped. So Wednesday is ARM Server Enterprise Ecosystem Day. There'll be a bunch of hardware here. That will be a really interesting day. We'll have a great keynote. Kiko Reese from Canonical is going to be the keynote that day. And then on Thursday, Networks Day, that will also be great too. So lots of great stuff planned. This is going to be the biggest and best Connect ever. There's over 600 people that are expected this week. And there's just so much going on, so be prepared for it. The meeting rooms, just to give you a little bit of orientation. So over to the left here, there'll be sessions, and far to the left, the Regency ballrooms are where all the steering committee meetings happen. There'll be sessions in the rooms over here. Every morning, the keynote will happen here. Tomorrow morning, we're back here at 8:45 a.m. for the keynote again. And then far to the right are these rooms called the Sand Pebble rooms, and the Sand Pebble rooms are where all the hacking sessions will take place. There's a bunch of them down there. So just to give you a little orientation. And if you just have a meeting and it's not a session, then those rooms are upstairs on the far end of the atrium. So that's where all the meetings will take place. So sessions over here, Regency room steering committees, hacking, and meetings upstairs. Okay? So we want to sincerely thank our two sponsors, ARM and HSA. They help make this happen. They help support this whole thing. We're very much indebted to them, so thank you very much. We really appreciate and value your support. And a lot of the great things that happened this week are a direct result of your support, so thank you. Lunch today is upstairs in the atrium. You don't need a ticket, but you need your badge. So be sure to use your badge. It's at 1 o'clock. Wednesday night is Jamboree night. We're going to have all sorts of fun there. It should be great. We're encouraging everyone to come in a superhero costume, but if you don't have a costume with you, don't worry about it. It's sign up. So please, if you haven't signed up, there are just a few spots left. Talk to the folks at the registration table outside and get your name on the list. We're going to have a blast. It will be right here. And our famous member services dinner is taking place on Thursday night. We have something very special planned. It's at a place called Sparky's Hot Rod Garage. A lot of interesting things will happen that night, a lot of surprises. We're inviting all the members to please join us Thursday night, but that's also by registration. Talk to Christine Dill. She's outside at the registration desk. Get your name on the list. Just give her your name. She'll put it on. This is going to be a blast, too, so please do join us. There's great Wi-Fi here. Ben Copeland from Linaro is overseeing it if you have any questions or issues, but in general, in the last few days in the hotel, from my experience, the Wi-Fi has been really great, which is a strong contrast from some other previous Connects that we've had. And of course, we're in Silicon Valley, so it all works very well. The password is actually in your badge, along with maps and things like that. So you can see the password in there. If you brought a device to the last Connect in Macau, it's actually the same password. So like I showed up here yesterday, and all of a sudden my laptop and phone, they just connected because it was all the same. It's the same SSID, same password. So that's all good. So that's just a little bit of the logistics. So what I'd like to ask you now is to please join me in welcoming George Gray, our CEO, for our opening keynote.
Thanks very much, Joe. So welcome, everybody. I don't think I've ever had such a good turnout first thing on Monday morning. So I'm very excited to see you all. Thank you all for coming. I think this is going to be our best and biggest Connect yet. And just remember that this is about collaboration, communication, and engineering. We're going to do more engineering this week than I think we've done in any previous Connect. We've got more space allocated for hacking. We've got more time allocated to open source community sessions and having groups working in the hacking rooms on everything they want to do this week. So I think it's going to be great. So I just wanted to look back a little bit. For those of you who don't know, Linaro is now 4 years old. We started in 2010 as a member-driven software engineering company dedicated to working on improving the open source community and the open source technology for the ARM ecosystem. The initial members were ARM, IBM, who've always supported open source and who remain a community member to this day, and 4 SoC vendors originally from the mobile space. And on day one, 20 engineers started in Linaro on just 2 projects. Firstly, the GCC toolchain, which has now turned into, I think, the dominant toolchain that's used across the entire ARM industry, and on kernel consolidation, which over the following year led to the adoption of device tree for the first time for the ARM architecture, which has led to significant improvements across the whole ecosystem. And that was 4 years ago. So today, we're 28 members, including still ARM and IBM. There are 16 SoC vendors who are members of Linaro, 5 open source companies, and 5 end users who are particularly driving their interest in leveraging the ARM architecture into their products. We have over 200 open source software engineers working on the ARM ecosystem around the world. And we're the equivalent of a $50 million software company after only 4 years and growing rapidly. The company is formed into a number of different structures overseen by the technical steering committee, who control the work that we do and deliver requirements for core development in the kernel, in power management, in security and virtualization, in the platform engineering team, and in the key product technologies that we provide. And over the last couple of years, we've moved into working on open source in an increasing number of segments as ARM, the ARM architecture and ARM devices, and the rate of innovation you're seeing in the ARM ecosystem has moved ARM more into new segments, including the enterprise group focusing on servers, the digital home group on set-top box, digital TV, the mobile group working obviously in the mobile space that's increasing itself, and the networking group focusing on networking equipment. So when we started 4 years ago, we had 2 projects. Today, we're working on all of these areas. In the last 6 months, we have touched all of these projects and made significant contributions to many of these projects. And that would not be possible without not only Linaro's engineers and assignees from all our members, but all of the other work that that's led to through the community. We are having a significant impact on improving open source across the entire ecosystem. And it just would not be possible without the initial idea that led to Linaro being formed and without this collaborative engineering effort that's happening between all of the members and the community who are investing in the efforts that we're leading. So thank you, everybody. I want to touch on some of the key projects that we're working on over the next couple of years. This is just the tip of the iceberg, but it's the visible tip. Some of these projects are very visible in the community and therefore define some of the view that the market has of Linaro. One is extensive changes that we are working with other architectures and the scheduler maintainers to put into the mainline Linux scheduler to deal with the future variety of not only ARM SoCs, but also other architecture SoCs. And this is about making the scheduler more aware of what the underlying topology of the hardware that Linux is running on. And ultimately, it doesn't matter whether it's a symmetric multiprocessor, whether it's an architecture like Big Little, or whether it's actually starting to be completely heterogeneous and use other forms of processing. This is going to be a big issue and have a big impact on all of us over the next couple of years. And that work is well underway. ARM, Linaro, and our members are participating in it. And it's important that everybody contributes to this. The open source community is about working together. No one solution is necessarily right. The process is working together to improve this technology for everybody. We're also clearly working a lot on Android optimization, particularly around 64-bit SoCs. OpenJDK, where a group, including Andrew Haley of Red Hat and Ed Neville in Linaro, have made huge steps in delivering a OpenJDK implementation for ARMv8 with full enterprise C1 and C2 JITs that are showing extremely good performance and have led to the delivery of not only OpenJDK, but also Java from Oracle. I'm also going to touch on Open Data Plane, which is the defining project of the networking group, and on some work that LHG is doing on security and creating a fully open source implementation of secure media playback, which can then be leveraged by multiple SoC vendors. And of course, Linaro also is putting increasing focus onto the products that you're using, the tool chain itself, the Linaro stable kernel, and the Lava continuous integration and cloud test platform that's a completely open source product and starting to see wide adoption not only in our members, but also outside Linaro. LNG is doing something really interesting, which is working on a project called Open Data Plane. In 2013, the LNG members got together and said, we have to have a completely open source cross-platform framework to create APIs for the data plane in networking equipment. Already, this team has delivered 2 versions, and the first 1.0 version will come out by the end of this year. Our members are working primarily on the ARM architecture within Linaro, but our members and others are already implementing this technology on ARM, on x86 using DPDK, on the MIPS and the PowerPC architectures. And this is a true example of cross-industry collaboration and is becoming recognized as an increasingly important part of the software-defined networking story and will become an underpinning of projects that are outside open collaborative projects like Open Daylight. So there's going to be a lot of discussion this week in the networking group and a lot of work going on to move this project forward. But it's pretty exciting, and I'd particularly like to recognize Raj Murali, who is the director of the Linaro networking group, who's tirelessly working to make this happen with some of the end users who are actually in the networking group. Another project that we've been working on hard over the last year that I'd like to particularly call out is the Open Portable Trusted Execution Environment. This is a full open source implementation of a trusted execution environment for ARM's Trust Zone and is now available today on GitHub at that address you see at the bottom of this slide. It's open and available to all ARM SoC vendors under a BSD license, and participation and contributions are welcome from everybody. We encourage you to look at it. One or two members who have looked at it have said it's a very full, complete, and impressively engineered piece of technology. It comes out of a huge effort by ST to open source this product, which was derived from work they originally did in the mobile world. And they've been working tirelessly with Linaro's security group to help get this project into the open source community. So a big thank you for ST to making it happen, and a lot of kudos to the Linaro security group who've helped bring this project into the open source community. And on that GitHub site, you'll find the client, the Linux drivers, and then the actual secure OS itself. Please participate in this project and contribute to it, whether you're a Linaro member or not. The Linaro stable kernel, a baseline for member ARM products. We're actually now in our second year of the Linaro stable kernel. And this means that the first version will, over the next few months, depending on input from the technical steering committee, move from having new functionality put into it to more of a maintenance function over the next year. And the focus will move on to the next long-term supported kernel from kernel.org, which is 3.14. The fact that 3.10 is used within Android and AOSP at the moment means that we may need to continue under the direction of the TSC to add functionality for a little bit longer than we were originally expecting. But that's a sign of our success, because it means that our members care about it and are using it. And we encourage you all to continue to do that. There are also versions of the stable kernel for the segment groups. So there's a version for Android for the mobile group, a version with the real-time patch set for the networking group, and a version packaged for the RDK that is used as the underpinning, the kernel is used as the underpinning of the RDK for the digital home group. For the first time in Connect history, we're going to do some live demos on stage. Unfortunately, one of the demos, a key piece of hardware required for the demo, is actually stuck somewhere in San Jose, and we're not quite sure where. But the fact that the missing piece is a piece of 4K hardware, and that we cannot do the demo on a low resolution monitor, is actually, I think, a really interesting sign. And I can assure you, you are going to see, or I am assured, you're going to see this demonstration later in the week during the various demonstrations that LHG are going to do and we're going to have on the demonstration day on Friday. I'm going to ask Mark Rogotsky, who's the director of the Linaro Digital Home Group, to come up and talk a little bit about what he's going to demonstrate later this week. Mark.
All right, thanks, George. Good morning, everyone. Unfortunately, we had a bit of a snafu with a component, as George mentioned, not available for our live demo, but we have a whole host of demos that are going to be available on Friday during the Demo Friday session. We have 3 member boards. We have 4 separate demos. I just wanted to take a step back real quickly and remind everyone that LHG was officially launched in May of this year, and since that time, all of the members have been collaborating together on several initiatives. And so most of the focus right now has been on the Linux-based RDK, and this is the foundation for the ARM SoC work on digital set-top boxes. So LHG has implemented changes to the streaming framework architecture, as well as innovations to the web rendering engine, and as well as abstractions to the graphics layer. So we've done a lot of work in the Chromium embedded framework area, a lot of work in the GStreamer OpenMax integration, a lot of work in various other areas, Western Compositor over the Wayland windowing protocol. So these are the kinds of things that we're going to see on Friday. So one of the demo we were hoping to have today, but we'll have later in the week, was on a member hardware board, the ST Microelectronics B2120 board. It's 4K graphics with 1080p video shown simultaneously. It's based on a set-top platform, which is a dual-core ARM Cortex-A9 with a graphics processing unit of a quad-core Mali 400. All of the work we do in LHG is based on the Linaro stable kernel. We're currently at version 3.10. All of the builds that we do are open embedded Yocto. We're on the DAISY branch at this point. And as I mentioned, we are moving from the X11 windowing system. We're looking at EGL, and we're looking at the Weston Compositor over the Wayland windowing system. So that's one of the demos, as well as a host of others on Chromium Embedded Framework and integrations of OpenMax with GStreamer. So again, I think I've jumped ahead. Reminder everyone, Friday, LHG Demo Day. There's a lot to see, and we look forward to seeing you there. Thank you.
Thanks very much, Mark. I'd now like to introduce Tom Gall, who's the director of the Linaro Mobile Group, and Tom's going to talk a little bit about what he's going to show you today.
So, Linaro Mobile Group, I am particularly excited to demonstrate to you today Android on ARMv8 on the Juno development platform. This is a really exciting thing to show. If you've been watching the Linaro website ever since June, July, August, you'll notice that Linaro has made available reference builds of Android for Juno. And so today, we actually have a Juno board. I definitely must extend my deepest appreciations to ARM for hand-carrying one of their Juno boards so that we could have this demo. And as you might say, Elvis is in the building, and he happens to be in the back. So what do we have here? Well, we have Android, and in this case, it's Android running with the AOSP master. So this is something that if you did a repo sync of the Android tip, you'd have the exact same source code. We are running with the Linaro stable-based kernel, of course, version 3.10. We have Mali support, so we have accelerated 3D graphics. We are using the trusted firmware, so it's UEFI, and all of this was built with Linaro's 4.9 GCC. So now I'd like to introduce Kazim Mohammed, who of course is the LMG tech lead, and he's standing in the back to do the demo. So Kazim, take it away. You don't have to, you can go ahead and keep watching here because it's on the screen right here.
I'm very happy and excited to have this demo run for you. So good morning everyone first of all, and welcome to Linaro Connect. So I have this hardware from ARM. This is the Juno platform for ARMv8, having ARM Cortex A57 and A53 with Mali integrated. So I have connected HDMI, and there is a good panel that Yuan brought for this demo specially. So I have Android already booted on this platform. So you can see here, and just for this demo, I'm going to reboot this platform. So this device is going for reboot. Okay. While this is rebooting, so I'll take this opportunity to take few names. So at Linaro, thanks to Ryan, Tixi, John Sturls, Mark Brown, and Android engineering team, Amit Pundir, Yonkin, Vishal and Vero, Yakub and Kanta from project management. So thanks a lot, and definitely the ARM team under Guliam, Dave Butcher, Sarban, Kevin, Ashok, and definitely the Google Android team, and for putting this together. This is really a great product on having ARMv8 running Android. So a round of applause for these guys, please. So they're going to change the way Android mobile is going to be. Well, this is still booting. So there are few LMG sessions that we are running today and across the week. So there are a lot of ARMv8 sessions that we are running. There is engineering team from ARM and Linaro who are at various sessions and also at hacking sessions. So please use this opportunity to connect with them, and please attend the sessions, and please don't forget to attend one of the important sessions today on building this AOSP community around ARMv8 Android. So it's today in the noon. Let me see if this works. So I just happened to find one of my favorite demos. So anybody is interested in playing? Let me see if I can hit it in the one shot. Yes, I did. So thank you.
Thank you very much, Kazim. George.
Thanks, Kazim. Definitely room for optimization there. I think we need to get that boot time sped up a bit. So LMG is doing great work, and our relationship with Google is strengthening. We've done a lot of work with Google, as some of you know. There was a blog posting recently about work we've been doing with QEMU that's helped Google enormously in terms of delivering the SDK for Android, and we're continuing to support them on that work. So moving on, we have one further demonstration. So my clicker stopped clicking, which is from LEG. And so I'd like to invite the director of the Linaro Enterprise Group working on the ARM server ecosystem, Andrea Gallo, to show you what he's got to demonstrate. Thanks, Andrea.
George. Our demo is running on 3 nodes. One node is the master, is the cloud master, is running OpenStack, and is running the JCloud plugin with Jenkins, and it's deploying Java test regression test, the JTreg, on the other 2 nodes, so that we can run multiple Java tests in parallel. The interesting thing is that all this is running on ARM 64-bit machines, and if you think about it, we're running Java tests on ARM, so we're using the OpenJDK 8 JIT. And Jenkins itself is based on Java. So we are running, again, Java on the controller node. And this is running OpenStack. So this demo is integrating together all the technologies that we have been working on for the last 2 years, OpenJDK, OpenStack, and it's showing the collaboration amongst Linaro members and the collaboration with Red Hat and Canonical. OpenJDK is a key project in cooperation with Red Hat, and OpenStack has seen incredible progress thanks to the collaboration with HP and Canonical. The demo is running on 3 Applied Micro Mustang boards. They are running Ubuntu Trusty. And I will hand over now to Andrew McDermott, technical leader for our cloud architecture work.
So as Andrea mentioned, there are 3 Mustang boards on the desk here. The first one is the Jenkins master, and you can see here the dashboard. What I've done for the demo is I've created a subset of the JTreg tests that we run on a daily basis. There are approximately 18,000 tests in JTreg, so we're not going to run all of those here. But you can see that we have this matrix, which is really convenient. As part of the build that we do for OpenJDK, we build both the server and the client compilers. And in the OpenJDK tree, there is the hotspot, langtools, and JDK regression suites. So we have this matrix which spans out nicely that we can spin up each of the configurations on a separate node. For the demo, I've been running this in a loop, so you can see that every 5 minutes this has been started. It's not running at the moment. But if we catch the time right in a few minutes, maybe it will do. So if we go back to the dashboard. So we can see down the left-hand side here that there's the master node, and this is running OpenJDK 8. And then on each of these images, which are virtual machines spawned via the JCloud plugin to OpenStack, they have a version of OpenJDK 8 as well. So throughout this, we're actually using OpenJDK 8 as much as possible for dog fooding, if you like. If we look at the OpenStack dashboard, we can see here that the other two boards on the desk here are Mustang 02 and Mustang 03. And we've actually provisioned those as OpenStack compute nodes. And if we look at the overall project, we can see that we've timed out. There we go. We can see that we're using some of the CPUs available from these two other boards. And if we look a little bit further down, we can see that these are the images which have been spawned by Jenkins to get the work done for the JTREG tests. One other thing I wanted to point out is that we've been running OpenJDK 8 and a Jenkins master in the Cambridge lab for about 6 months now, and the tests that we do are pushed from an ARM server, and you can see the results here on openjdk.linaro.org. Okay.
If you want to know more about ARM servers, please join us on Wednesday at the Server Ecosystem Day. Thank you.
Thanks very much, Andrea. Okay, so that was our first live demos. We got through 2 out of 3 of them, so that's not bad. Well done, everybody. So I just wanted to touch a little bit on a couple of industry trends and talk a little bit about some of the things that are happening over the next, we expect, 12 months. It's pretty obvious that the ARM architecture is really starting to extend into segments other than mobile, ranging from IoT at one end of the scale all the way up to high-end servers. And this is really driven by something I've talked about before, which is the accelerating rate of innovation within the ARM partnership. There are more and more devices coming. There's more and more differentiation and innovation, and that's what draws end customers to the ARM architecture, because they're faced with more choice than ever before, and therefore ultimately lower costs to deliver more performance. But this also presents huge software challenges to us all. The SoC complexity and the speed of innovation is placing increasing demands on the delivery of standardized software that will work across multiple SoCs. And one of the really interesting trends is that the distributions themselves and end customers are starting to recognize that successful open source software depends on SoC support in the upstream kernel and other projects. And if you look at some of the projects like the Chrome project, obviously the server ecosystem, because this is where it's come from, are demanding and requiring SoC vendors to have upstream support for their SoCs. And increasingly, if you don't work upstream, which historically many of the mobile vendors haven't needed to do, you become uncompetitive for certain projects. And I see that trend increasing and accelerating over the next year or two. We're working with a lot of the open source projects from an operating system and a distribution point of view. Obviously, with the Linux Foundation and with the Octo project, we've been using that not only in LHG, but we're also using it in the networking group. We're starting to engage with the Chrome project and doing work on Chrome. And Google at Google I/O this year announced that they're bringing out 3 versions of Android in the next release, in addition to the standard mobile version, so Android Wear, Android TV, and Android Auto. And I think that's going to significantly affect the segment groups and the work that they do to embrace this new platform. And finally, of course, in the server space, we have Ubuntu, Fedora, Red Hat, and in the networking group, companies like Enea who are working on distributions and software upstream for the networking equipment marketplace. And a feature of this is that collaboration is everywhere, right? Linaro is working in the ARM ecosystem, but is now increasingly working in other ecosystems as well. There are two real categories. One is where we do most of our work is in the SoC-dependent projects, so things like the kernel itself and the associated projects, things like AOSP for Android, OpenJDK for Java, but we're also seeing increasing interest in our members in demonstrating and optimizing other major industry projects that we're starting to affect. And these are built with the same collaborative open source software model. Typically, they're architecture independent, but there are huge opportunities to optimize some of these projects for the ARM architecture. And that's something our members are very interested in doing, and that we will continue to work with you on working out which projects are most important and where Linaro should contribute and be a part of. Part of this clearly is Linaro itself is not only acting as collaboration for the ARM ecosystem, but is also acting in the wider open source community. And I'm very pleased that since we last got together, we have become formally a silver member of the Linux Foundation, not on behalf of our members, but as Linaro, because as Linaro, we are together with all of the members who are also members of the Linux Foundation, increasing the amount of influence and activity that we're generating around the ARM architecture in the open source community. And I'd particularly like to congratulate Grant Likely, who's, stand up Grant, who's in the front row here. He was recently elected as the chair of the Linux Foundation Technical Advisory Board and will represent the tab on the Linux Foundation Board of Directors. Grant has worked tirelessly, as many of you know, in the office of the CTO, particularly on boot architecture, and I'm very, very pleased for him that all his efforts have been recognized by his peers. So congratulations, Grant. We today also welcome the Linux Foundation as a Linaro community member alongside IBM. And we believe that there are a lot of common threads between what the Linux Foundation does and what Linaro as a software engineering organization does, and we expect to see increasing collaboration between the two organizations. We also ourselves are expecting to continue to grow, reflecting the importance of open source software in the industry in which we all work. And our members are going to come not only from the SoC vendor space, but also from increased, we think, membership from distributions and key open source software providers and from end users. So I'm now going to do something that we haven't done before, which is we're going to talk a little bit about some things that we're not going to share today. Trailers in the movie theater. One of the things we're working on is a server cluster based on ARM v8 architecture hardware to accelerate the ability for ISVs to deliver deployment-ready software to the ARM server and other enterprise markets. So what we want to do is help the open source community, operating system vendors, and ISVs work together on pre-publicly available hardware from our members to be able to test and validate and benchmark their software running on early access hardware. So Linaro is not going into the cloud business. We're not going to compete with Amazon, but what we want to do is enable software developers, particularly ISVs, to get early access to unannounced hardware. We're initially doing this with Applied Micro and with ARM, and we're deploying a cluster of servers that will be available on a by-request basis to independent software vendors who want to validate and test on ARM hardware. I also expect other members to add their hardware to this facility, providing a one-stop place where ISV vendors can run their software and verify that it works across multiple Linaro member hardware platforms. And we welcome participation by any Linaro member into this deployment facility. You do need to provide us actual real 1U or more U servers that we can put in racks and not just development boards. This is for devices that are ready to deploy that aren't necessarily available publicly yet. And it will give software developers a heads up and an advantage on being able to validate that their software works before you actually ship publicly. Works cross-platform. The second initiative is the Linaro Community Board Program. One of the things that Linaro wants to do is help get hardware earlier into developer hands. It's been very frustrating in some ways that Linaro engineers have not all got ARMv8 platforms on their desks. We do have a number of Junos, but as most of you know, they're big development boards like many SoC vendors use for bring up of their own SoCs, and they're not really suitable for widely seeding across a big software community. More hardware would help us. And so what Linaro is doing about this is we're going to be working with our members to create a community-oriented website to encourage software developers from the community to work with Linaro on optimization of software, particularly for ARMv8. By Next Connect, my goal is to get at least one low-cost ARMv8 board, and preferably more than one, on every Linaro engineer's desk. And not only Linaro engineer, every ARM software engineer's desk. Everybody should have ARMv8 hardware by Next Connect. And this will help also drive work that John Mad Dog Hall has been doing over the last 12 months in preparing for engagement on a much wider basis with global universities to put programs in place to help them have a platform for getting access to low-cost hardware and optimizing software specifically for ARMv8. We think this is a really exciting project. We're looking forward to getting this hardware into not only our hands, but also to all of our members' hands. This is a work in progress. We're not ready to talk completely publicly about it, other than the fact that I'm already talking publicly about it. But if you want more information, please come and talk to me or one of the other Linaro executive team. The third project that we're working on was referred to by Joe earlier. I'm delighted that we have Paul Eremenko, who is the head of Project ARA at Google ATAP here, to talk to us about this innovative, disruptive, and really fascinating project to work on. So please welcome Paul Eremenko from Google.
Good morning. What if we were to ask better questions of our phones? Like, what if a phone could see in the dark? Or what if a phone could test if water is clean? What if you could share the best parts of your phone with your friends, with your family? Or perhaps not in the Bay Area, but with a village? What if a phone could? So we think that a phone should. And so Project ARA is about opening the mobile hardware ecosystem. It's about making the creation of mobile hardware more like the creation of mobile apps by lowering the barrier to entry, by increasing the number of participants in the ecosystem, by enabling developers to sell directly to the consumer rather than having to go through an OEM, and by giving developers new hardware design tools that are free and that make hardware design more like software development. Now, in addition to the what questions, we also wanted to ask why. Why do it? Why does it matter? And so I find this photo to be a particularly poignant reminder. It's titled Signal. It's by John Stenmeyer from National Geographic, and it depicts migrant workers in Djibouti trying to catch a cell phone signal from neighboring Somalia. And I think it's a stark reminder of the fact that, yes, there's 1.5 billion smartphones out in the world, but there are also 6 billion people who are not connected to the mobile internet. And delivering the mobile internet to those people could, in fact, be world-changing. So we asked ourselves, how would we do that? What would it take to deliver the mobile internet to the next 5 billion? Now, a single device, this is almost impossible to do with a single device. There's a diversity of wants, needs, likes, and budgets that's insurmountable. So we looked for inspiration from other industries. First, we looked at automotive. Of course, in the early days of automotive, there's the infamous Henry Ford quote that says that you can have it in any color so long as it's black. It's good enough for everyone. But as the industry matured, a power user base emerged that took customization to all sorts of extremes. And what's depicted there is the local Motors Rally Fighter, which is a community-designed and community-built vehicle. Now, a modern mass-market car today has about 30% of its value that's tied up in user-customizable options. So these are both functional options, like engine size, as well as aesthetic choices, like upholstery and exterior. It wasn't so long ago, maybe a year or two ago, that when you bought a new smartphone, your choice was pretty much the same as the early Ford Model T. Would you like it in black? Would you like it in white? So last summer, summer of 2013, we undertook a project to create an open, hackable phone. We were at Motorola at the time, and it was called the Moto Maker phone. We basically attached an Arduino board, we unlocked, rooted the phone, and pinned out some of the data buses to the Arduino. Got in a truck and went around the United States, visited 12 universities, maker fairs, and held makeathons. So 48-hour format, and had some of the best and brightest design and engineering students in the country see what they could do with open mobile hardware. And the diversity of things that emerged was really an exciting proof point for us. We saw things like a glove that could interpret ASL and convert it into text messages. We saw students using a phone and the gyro and accelerometer sensor suite in the phone attached to a skateboard to monitor the quality of the terrain that the skateboard is traversing and share that with other skateboarders in the area via Google Maps. We saw an optometric examination suite as a module that attached to your phone and did a series of exams for your eyes. So to us, that was really a demonstration and an eye-opening experience of the kinds of things that emerge if you create an open ecosystem. So we wanted to do better than cars. We wanted to create a modular platform around mobile. And in order to do that, we thought that it would be useful to look at some examples from history of successful platforms. I personally am an aerospace engineer, so I'm partial to the example of the B-52, the Stratofortress, which is a strategic bomber that entered service with the US Air Force in the 1950s. Remarkably, the B-52 is not only still in operation, but is estimated to serve with the United States Air Force for another 20 to 25 years. Now, by the time this airplane retires, there will not be a single component, from rivet to integrated circuit, that was there in the original 1955 aircraft. Yet morphologically, it will still be recognizably a B-52. The different pieces of the aircraft will have gone through varying number of generations of changes, 1 or 2 generations on the structural side, and 5, 6, 7, 8 generations on the battle management system and the electronics. Yet it retains the overall recognizable feature of being a B-52 and being a remarkably flexible and upgradable platform. Now, closer to the mobile space, perhaps, is the IBM System 360. Introduced in the mid-1960s, a typical core configuration was about $100,000 in then-year dollars. A typical installed configuration, also in then-year dollars, was about $5.5 million. What allowed for this 50x increase in size of the peripheral ecosystem vis-a-vis the actual system core? And what allowed it was the fact that it was the first open modular platform. Now, you might argue that in mobile, we have modularity today. There's a USB port, there's an audio jack, there's Bluetooth, there's Wi-Fi. I can add all sorts of modules to my phone, and there are some, in fact, some examples out there. Square credit card reader, there are chargers, there are headsets, and other sorts of things. Yet the size of the modular peripheral, so to speak, ecosystem around smartphones today is about 7% of the overall smartphone market. Now compare that to the 50x that was realized for the IBM System 360. And so you might ask yourself, well, why is that? What is it about that makes it kind of anemic? And the hypothesis that I'd like to proffer for you is that unlike the IBM System 360, and perhaps more like the B52 example, the phone is a physically constrained, the actual exterior of the phone is a heavily physically constrained object. And what you have today is this Christmas tree of stuff that hangs off of your phone that attaches via a variety of wires. And if it's wireless, then it has a power charging tail that you have to drag behind it. So it is not a integrated monolithic whole. And I use the word monolithic specifically in reference to a modular design in sort of in stark juxtaposition to it. So we asked ourselves the question, could you make a modular device that is both delightful, but is also expressive of users' functional preferences and of their aesthetic preferences, because those preferences are so diverse? And so we also set ourselves quantitative target with respect to each goal. And in the case of this particular goal, we wanted to try and attain an order of magnitude increase in the subjective user perceived value of the device from the customization features, from the functional and aesthetic customization features that you could get from making it modular. We also wanted to make it affordable yet aspirational. Affordable means that it is accessible to the feature phone crossover price point. So that translates to a bill of material cost in the $50 to $100 range. Not necessarily price, but at least a bill of materials cost. Yet we also wanted to make it aspirational. We wanted users to aspire to a phone that might be a $1,000 device, that might have an extraordinary camera, a high-resolution display, personal medical diagnostic things. So we wanted to be able to configure an order of magnitude variance in bill of materials cost off of the same platform. I mentioned that we also wanted to make hardware development more like software development. And the metrics associated with that are that we wanted to have hundreds of developers. Ultimately, we aspire to a developer ecosystem around Ara that rivals the Android app developer ecosystem, but we'll settle for a couple hundred for now. We also wanted to give developers a new set of tools that would allow them to create a module that, in essence, is correct by design, so that there is only one build spiral required. In essence, this is similar to what VLSI design has come to in recent years, where the first chip out of the foundry is usually correct by construction, instead of having 4 to 5 build spirals as is typical in mobile today. And lastly, we wanted to exploit a DARPA-style project structure, and I'll explain exactly what that means. But in essence, it comes down to the fact that from idea to market pilot, we constrain ourselves and hold ourselves to 24 months. So let me talk a little bit more about this DARPA development model that we're employing on Project Ara. If you notice, I come from not just Google, but Google ATAP. It's the Advanced Technologies and Projects Group. It's headed by Regina Dugan, my boss, who was President Obama's first appointee as DARPA director. DARPA is the Defense Advanced Research Projects Agency. For those of you who are unfamiliar, it is the agency that originally created ARPANET, the Global Positioning System, radar stealth technologies, a variety of rocket engines, and other iconic innovations. And there are 3 things that are key to the DARPA model of innovation and that we're trying to exploit in the private sector in ATAP. And those are projects, people, and partners. On the project side, as I mentioned, one of the things is we try to constrain projects to a finite duration. And projects live in what's called Pasteur's quadrant. And this is a construct from a political scientist named Don Stokes. And he basically thinks of mapped innovation into 4 different quadrants. On the horizontal axis is consideration of use, meaning how applied or what is the utilitarian application of the technology. On the vertical axis is the quest for fundamental understanding or basic research. And so on the quadrant on the vertical axis is called Bohr's quadrant. It's pure basic research. It's doing research for the sake of gaining scientific insight and nothing more. On the horizontal axis, you see Edison's quadrant. which is pure applied research. It's wanting to put something into the stream of commerce and solve some everyday problem. In the upper right, however, is Pasteur's quadrant. And Pasteur's quadrant is use-inspired basic research. In essence, taking fundamental insight, breakthrough basic innovation, but tethering it to a moonshot practical application that is extraordinarily compelling. And so that's where ATAP projects live, in Pasteur's quadrant. We also have an interesting philosophy with respect to people. We bring people in for a very short period of time, and we have a very, very small team that operates within Google. So on Project Aura, for instance, which is a sizable effort to make in essence, a smartphone, we have 5 Googlers working on the project. Yet we have 350 or more people, and it fluctuates from week to week, outside of Google, across partner organizations that include large companies like Toshiba, small companies that you've probably never heard of, and other partner organizations like universities and actually Linaro, and I'll talk more a little bit about that as well. And the reason that we use external partners is because it lets us turn on a dime, and it lets us capture world's best-in-class talent, people that I could never recruit to pack up, move to Mountain View, and work for Google full-time. So back to what it is that we're developing. The best metaphor that I have been able to come up with for what we're after, the level of customization and the level of cultural ubiquity, is food. And so, in fact, the inspiration for the industrial design of Project Aura came from the Japanese lunchbox, the bento box. The bento box is kind of a remarkable object. What it allows the chef to do is to combine a wide assortment of very disparate dishes and tastes and flavors and ingredients that are disparate both visually and in terms of their flavors, and combine them into a coherent meal. A meal that's made cohesive by something that's very, very simple, that's very, very elegant, and that celebrates both the diversity and the uniformity of what's being provided to the consumer. And so that's where the Aura industrial design came from. Instead of concealing the modularity, we wanted to celebrate the modularity of the device. We also wanted to overcome the preconceived notion that most consumers have, that modular equals brick-like or block-like or Lego-like. We wanted to make the modules sleek and watertight and pebble-like in appearance. So we harnessed 2 technologies in service of this objective. The first one is trying to not have mechanical latches or mechanical connectors. Try and make the module completely, as I said, watertight and pebble-like. This is an electropermanent magnet. An electropermanent magnet is actually a decades-old technology that's used in industrial crane applications that we miniaturized from something that can lift a car to something that can lift something about the size of a small kitten, about 30 newtons of force. An electropermanent magnet is is a hybrid between an electromagnet and a permanent magnet. It has an on state and an off state. It can switch between those states with a short current pulse, but is actually a passive component in both of those states. The second technology that we harnessed in service of our industrial design vision was that of contactless data interconnects. This was the trade space that we explored, and actually in the last couple of weeks we've settled on the horseshoe inductor to be able to connect the data between the modules and the frame of the device, what we call the endoskeleton, to transmit the data. Now, this is not a trivial problem. We use the MIPI MPHI layer 1 protocol, which is a nice modern protocol. It has a variety of different power states, and it has modes from PWM, a low-frequency PWM mode, all the way to a 10 gigahertz high-speed BR3 mode. And so providing a contactless interconnect that allows efficient data transfer over that full spectrum of frequencies has been a challenge. Now, let me talk a little bit more about what is the electrical architecture of the device. We've embraced the industry standard MIPI Unipro stack that lives layers 2 through 4. At layer 1, as I mentioned, our objective design utilizes the MPHI protocol. We have split the design of the Aura platform into 3 design spirals, all of which are conducted quite openly. So we expect to have a developers conference after each one. We had one in April that celebrated the release of the Spiral 1 design. and we document each release in what we call the MDK. And the MDK is an analog, is our hardware analog of the Android SDK. It's the Module Developers Kit. And it documents the platform and allows a module developer without any relationship to Google, without any relationship to any of the partners on the project, to be able to create a module that will work, that is guaranteed or assured to work with the other modules in the device. So compositionally correct. So the Spiral 1 platform demonstrated the Unipro protocol. It also demonstrated a flexible power bus where any module can be a power source, power consumer, or power storage device. It implemented a lot of the network processing in FPGA, so the phone has about 10 minutes of battery life, for those of you who have done FPGA development, and heats up like to a crisp. But nonetheless, it demonstrated the basic technologies, and we believe that it was the first real instantiation of user-serviceable modularity on a device, where the consumer or the user could replace the modules of the phone and make it work. Now, we are currently in the midst of our Spiral 2 development effort, which looks like it'll culminate in the October-November timeframe with a new release of the Module Developers Kit, as well as a prototype device to prove that our platform does in fact work, or is capable of working. We have one of our partners on the project. I mentioned Toshiba as an example. Toshiba is in fact the entity that's developing a set of bridge ASICs that convert legacy protocols, so everything from I2C, USB, SDIO, and bridge them to the Unipro network. And that's pending the native adoption of Unipro in silicon throughout the industrial base. Toshiba is also developing a Unipro switch ASIC. They by no means have exclusivity or monopoly on the Unipro hardware ecosystem. They're just first to the party. But we're actively soliciting new entrants into that ecosystem as well. And so what's displayed here, by the way, are 3 canonical examples of modules: an application processor, and I'll come back and talk more about that in a bit, a display module, which could as well be a camera or something else, and a peripheral module. And we have 2 different flavors of bridges, basically a big bridge that serves APs, displays, and cameras, and a little bridge, or general purpose bridge, that serves some of the lighter weight protocols used in peripheral modules. Now, as soon as we finish Spiral 2, we'll embark on Spiral 3. Now, Spiral 3 is scheduled to run from November through Q1 of 2015. And we anticipate a couple of interesting innovations there. First, it'll be our design spiral that actually implements the pre-production variant of a prototype phone, so something that could plausibly go into a consumer's hands. It'll implement the inductive contactless data interconnect for the first time. And also for the first time, we will demonstrate native Unipro in silicon. So we recently announced a partnership with Rockchip, a chip maker in China that's an ARM licensee. And Rockchip will be making a quad-core A7 processor with a native Unipro general purpose interface, over which all of the display, camera, and other peripheral or other module traffic will go over a single Unipro interface instead of having an assortment of a dozen or more different interfaces. And we're similarly working with display and camera vendors to try and precipitate and accelerate the native adoption of protocol standards like CSI3, with storage vendors for protocols like UFS, all of which are Unipro-based protocols, so they can speak natively to the ARA on-device network. Now, I promised to talk a little more about APs. Now, today, in today's world, the AP serves not just as a CPU, not just as a GPU, not just as an ISP, but also as a network hub. There's, as I mentioned, almost a dozen in many of them, and I'm certain that I'm preaching to the choir, different protocols that the AP has to communicate across to the various devices in the mobile phone. Now, the world according to Project ARA is that an AP should be just that. It should be an application processor, and its principal function should be to perform computational processing, computation. And the networks leave the network switching to us. So the Unipro switch and a small supervisory controller, which controls the switch and also does the power management functions, is the only thing that lives in the frame of the device. So that is the only core to the system. The AP becomes a module. That module could or could not have the GPU or the camera ISP integrated into it. We take no particular position as the curators of the platform on the correct partitioning of functionality across modules. So we believe that both highly integrated SoCs and disaggregated CPU-only type processing is possible in the ARA platform, and consumers will speak as to what integration versus disaggregation of functionality they prefer. And I've lost the clicker. So we have developed a notional design of what an ARM SoC might look like with a general purpose UniPro interface. And basically, and I've mentioned this already, UFS, CSI3, DSI2, all of the next generation MIPI protocols are native to UniPro. But we also expect other peripherals that would traditionally speak USB or SDIO to speak over the UniPro controller as well. Now, lastly, you might wonder, what about the software? And in fact, some pretty severe changes are necessary. Android is not designed today for dynamic hardware configurations. And so there are two major categories of modifications that we're making to Android. We're delighted actually to be working with a team from Linaro to make those modifications. We are changing the framework, the Android framework, to be able to support the hot plug of various hardware peripherals. So the ability to have dynamic configurations of the device hardware throughout its operational cycle. And we're also creating at the kernel level, at the Linux kernel level, a set of generic class drivers for UniPro devices, very similar to the way USB device classes are implemented today. We expect that all of the modules in the ARA ecosystem should be either class conforming and therefore fit neatly into one of the UniPro device classes, or non-class conforming, in which case they have to have a user space driver. And the reason for that is done for security, from a security perspective. That we don't want drivers from third-party module developers to live in the kernel. So we're working on a pre-release version of Android L, to make all of these changes. We expect that they will be complete and an end-to-end demonstration in the end of Q1, early Q2 of 2015. And the Android team has committed to then mainlining those changes into a future release of Android. In case you're wondering, I wanted to show you what an ARA module looks like under the hood. This is a Spiral 1 Wi-Fi module. One of those big hunking blocks over there is an FPGA, and so that will obviously be significantly smaller once we move to an ASIC implementation of the bridge. This particular FPGA converts from SDIO to UniPro. Further on the right is the Wi-Fi chipset. You can see there a small antenna connector in the upper right. The pins are the spring pin proxy, if you will, that we're utilizing for now in place of the inductive pads. Once we go to the contactless data interconnect, those will disappear because the inductive pads are just a conductive plating on the bottom of the PCB. So that should free up significant PCB real estate for developer-specific functionality. And in the corner, you see two hand-wound electropermanent magnets. We're working with Foxconn to create production volume, production grade, and production cost version of those electropermanent magnets that look much nicer. And the earlier photo was of a production variant. And then you see lots of discrete components that are needed to actuate the EPMs, do the flexible power management that I described, and all of those will go into a SIP package, so that again, from a developer perspective, the creation of an ARA module should be a relatively straightforward activity, whether you want to do it yourself or pay an ODM or a contract manufacturer to do it. So we've had tremendous enthusiasm for the ARA platform from the developer community. I mentioned our first developers conference, which happened in April, had 6,800 participants in total. We've had about 10,000, a little over 10,000 downloads of the module developers kit, and we had 2,600 applications for dev boards, for developer hardware, for Spiral 1 developer hardware. So we are planning, we don't have specific dates, but we are planning a second developers conference that will run through the second spiral of the platform, and will showcase some of the new Android functionality and Linux kernel functionality for Unipro devices in the December timeframe. And we've also announced a small one and plan to announce a much larger developer prize challenge that basically incentivizes developers to develop for the platform and to enter the ARA ecosystem. If you'd like to have a look at the MDK, there is the URL. It's a simple click-through license similar to that of the Android SDK. And otherwise, you see it sort of also happens to be the first open reference design for a smartphone that's completely freely available on the internet. So all of the schematics, all of the drawings, and all of the code that we have to date is linked from that URL. And with that, I am finished.
All right, floor is offered to answer a couple of questions. We're nearly out of time. If anybody's got a question, now is your opportunity. Well, I know we've got some backward people. The question was, what about security implications?
Yeah, so it is in fact a broad question. One immediate comment is that it's probably impractical to share RAM, just from a latency perspective, right? So the Unipro bus can get down to a couple microseconds, but you're still not in the nanosecond territory where you could have RAM that would be external from the CPU on a different module. So most likely the various modules would, if they need RAM, would have to have some of their own working memory. Now, security is a big topic, obviously, and is an exciting topic. I think we create all sorts of new attack surfaces, but also all sorts of new flexibility to counter various types of security issues. And so I'm not sure that we have the time for me to do a coherent answer on all of the broad-ranging topics. But in short, we expect a lightweight certification process, but a certification process that at least ensures that modules don't melt or explode or fry your brain before they get into the module marketplace. Now, you can sell out of band, right? So we're not going to prevent developers in the same way that you can get an Android app not from the Play Store. We wouldn't forbid it, right? But in order for us to sell a module, we have to make sure that it's not actively nefarious. We preclude third-party driver functionality living in the kernel, right? So it has to live in user space. So it could only do so much damage. And we're looking at implementing encryption across the bus in order to be able to authenticate and protect the data that's flowing around the bus. So that's a top-level answer. Obviously, devil's in the details.
One more.
Yeah, so the question was whether modules can be hot swapped while the device is running. And yes, they can. So I'm remiss in not emphasizing that point. Everything other than the CPU, obviously, which it sort of doesn't make sense necessarily. It's not clear what it means to hot swap a CPU. But aside from that, we expect that most display is also kind of a hard scenario. But aside from that, most modules would be hot swappable. And that includes, actually, potentially most interestingly, it includes things like batteries and cameras, right? Those are probably the two most compelling use cases. And in order to hot swap a battery, there's a very small reserve battery that lives in the endoskeleton that provides some seconds of runtime for the device in a low power mode while you swap the primary battery.
All right, thank you very much, Paul, for taking time to come and visit. Okay, so that's it. Time to get to work. Good luck, everybody, and we'll reconvene tomorrow here.